Welcome back. So we are learning about how we can find the equivalent inductances. Okay, let's have a look at another complex example. So in this example, we need to find the equivalent inductance, and all inductance are basically 6 millihenry. Okay, so again, like this is 6, this is 6, this is 6, 6, 6, and 6. Like it could have different values, but that is not important. We need to understand the concept, like how we can find the equivalent. So the rule is simple, like we are doing in the previous examples. Label the nodes. Okay, so like this is my first node. Let's label this as A, right? And notice that this is not just the A. Okay, because why I raise this one? Because if I start from here, come back here, so this complete is basically the same node. Remember, like labeling of the nodes and identifying the nodes, this is very important. If we do that correctly, half of the problem will be solved. Second node, if I look at this one, this whole thing is basically the one node. Let's call this node B. And lastly, this one is basically my node C. Okay, so again, labeling of the node is very important. So if we do that correctly, our half of the problem is basically solved. Okay, we don't have to worry at all about the anything else. All right, moving on. So what we can notice here, let's say uh, this 6 milli, this is connected between node A and node B, right? This 6, this is also connected at A and also at B. It means 6 and 6 parallel, right? Oh, there is another 6. What about this? This is also connected at A and this is also connected at B. What does this mean now? This means this 6, this network, okay, all these three are basically in parallel. So 6 parallel 6 parallel with 6. Okay, so 6 parallel with 6 parallel with 6. Okay, that will give me a basically simple inductance of 2 millihenry. Okay, and this 2 millihenry is coming where? This is coming between node A and B. Okay, so let's draw that. Like this is my node A and this is my node B. Okay, this one second one. So between node A and B, now I have, like this is A and this is node B, I have a inductance of 2 millihenry, right? This one parallel. Then at node B, what I have another 6 milli, right? This one, like this is connected at between node B and C, and we have another one here. This is 6 milli coming from here. Okay, this one. Then we have this one. This is connected where? This is connected between node A and C. So basically, this is node A and this is node C. So this way we can redraw this circuit to this one. The next become very easy, right? This 6 and 2, they are in series. Okay, so 6 plus 2, that will become 8. So this 8 become parallel with 6. So if I write L equivalent, that will be basically 8 parallel with 6. Now whatever parallel we are getting, that is becoming in series with this 6, right? So plus 6. So if you simplify this one, this comes out to be 66 over 7 millihenry. So that will be the equivalent inductance for this case. Thank you so much.